So from our question 2, we're simply given that what at a temperature of 5 Fahrenheit, 50 degree Fahrenheit, sorry, the viscosity of a fluid was found to be what 0.1 Newton seconds per meter square and what 0.001 Newton seconds per meter what square. Now what's the question? They are simply asked when the temperature is 40 degrees Celsius, find the general expression for the what viscosity and as a function of this. So what you are asked here is to derive, to bring out the equation for viscosity. Find the general expression of viscosity as a function of this. So you have to bring out the equation for viscosity when your when your temperature is not given. That's the first thing you do to get the equation. Now the second thing is to get what the viscosity at 70 what degree Fahrenheit. That's your question. Now for the first thing here, the first thing is to bring out your what? Your given data, right? Now your given data is stated temperature 1 is what? 50 what degree what Fahrenheit. So you have to convert Fahrenheit to Kelvin. Now if you have to convert Fahrenheit to Kelvin, what do? You recall the equation for converting what Fahrenheit to Kelvin that is stated to be what? Fahrenheit minus what? 32 times 5 divided by 9 plus what? 273. So this equation is used to convert what? Fahrenheit to Kelvin, where you simply put your Fahrenheit value here and you punch your calculator to get your value in Kelvin. So what do? You are putting what? 50 minus what? 32 in bracket times what? 5 divided by 9 plus what? 273. Now if you do this, you punch this on your calculator, you simply get the value for your what? Temperature 1 in Kelvin. And what's the value? 283. So I got 283 Kelvin. So you can also convert Fahrenheit to degrees Celsius if your question was asked to leave your answer, your temperature to be in degrees Celsius. But since we are not asked to leave our temperature to be in degrees Celsius, we go on with what we have here. Now from our given question, we have your U1, which is your dynamic viscosity, the initial dynamic viscosity to be what? 0.1 Newton seconds per meter square. So you simply have 0.1 Newton seconds per what? Meter square. Now what is that telling you? That's telling you for your case 1, you simply have a given equation to be what? 0.01. So you have 0.01. Is it 0.01? No. You have 0.1 and 0.1 will be equal to a exponential raised to the power of what? B divided by what's now your temperature? 283 Kelvin. So this is your what? Equation 1. Now from your second equation for your case 2, you were given your temperature here to be what? 40 degrees Celsius, and you are given your viscosity to be what? 0.001 Newton seconds per meter square. So if you impute that, we'll simply have that our temperature here was given in Celsius. So what do? You convert your Celsius to what? Kelvin by adding what? 273. So if you punch your calculator, 40 plus 273, and that will give you what? 313 Kelvin. So since you've gotten 313 Kelvin, your equation will now be what? 0.001, and this will be equal to a exponential raised to the power of what? B divided by what? 313. Are we together? So this is your what? Equation what? 2 from your question given. So we've gotten equation 1 and equation 2. So what do? You solve your what? Both equations simultaneously. Solving both equations simultaneously, we are going to divide equation 2 by what? Equation 1, such that we'll have this to be what? 0.1, and this will be equal to a exponential b divided by 283, and this will be dividing what? 0.001. Here you'll be dividing this with what? A exponential b divided by what? 313. Are we together? Now what do? The concept is keep this to be what? B multiplied by 1 over what? 283, such that when you punch 1 divided by 283 on your calculator, you simply have a certain value to be what? from what I have from my calculator, I have that 1 divided by 283 is simply giving me what? 0.0035. So what I have here is actually what? 0. What? 0035. So what we have here should be 0.0035b, and on the other hand, b times what? 1 divided by what? 313. And if you punch 1 divided by 313 on your calculator, you simply get what? 0.0032. So what I have here is 0.0032. So we succeeded in getting both your first parameter and your second parameter for both powers. Are we together? So we are going to impute this back into our equation and get what will be our what? Exponential. Now if you do that, you simply punch 0.1 divided by 0.001 on your calculator, and that will give you 100. So if you punch your calculator this, you simply arrive on your left hand side of your equation to be what? 100, and 100 will be equal to what you have here. Your a can cancel out a here. You are left with what? Exponential raised to the power of what? 0.0035. So what you have here will now be what? Exponential. So you simply have here to be So you simply have here to be what? Exponential raised to the power of what? 0.0035b dividing what? Exponential raised to the power of what? 0.0032. Are we together? And this is your what? B as well. So what do you have here? You simply apply the law of logarithm that says since you have same powers with since you have same values with different what power, what you do is you subtract their power. Now in doing that, you simply have this to be 100 will be equal to exponential raised to the power of 0.0035 minus 0.0032. Are we together? Remember, this is having what? B outside. So since it's having B outside, what you do is you punch your calculator for your given powers. Since your powers are given here, get the value for your power. So you have 0.0035 minus 0.0032, and that will give you 0.003, right? So what you have here will be what? 100 will be equal to exponential raised to the power of what? 0.0003b. Are we together? Now the next thing is to remove your exponential. That's what we did in our previous example. Removing your exponential, what do? You introduce what? Ln to what you have here. So you're introducing ln to both sides of your equation. On this side of your equation, you have ln what? 100, while on the right hand side, you simply have what? Ln exponential raised to the power of what? 0.0003b. Now remember, while you are introducing your ln, you are introducing your ln in the sense that your ln is going to cancel out your exponential. So if your ln is cancelling your exponential here, you are left with ln 100. So what you do is you punch ln 100 on your calculator, and ln 100 will simply give you what? Ln 100 will simply give you 4.605. So what you have here will be what? 4.6052 approximate 2, and this will be equal to what? 0.0003b, right? So what you simply do is we can find b from our given question here. Divide here by what? 0.003. You divide here by what? 0.0003. So what are you now left with? You are simply left with your b to be, you will simply punch your calculator, 4.6052 divided by 0.0003, and your b will simply give us what? This will simply give us 15350. If the answers are correct, drop a thumbs up on the comment section. Now from what we have here, we've already gotten our equation 3, which was b. So we can call this equation 3 such that we are going to substitute equation 3 into any of the equation, either equation 1 or equation what? 2. So let's substitute into equation 1. But remember, if you are to substitute equation 3 into equation 1, we have that for our equation 1, we had this what? Equation. So what you simply do is you rewrite this equation so the examiner will understand what you are doing. So if we write that equation, we'll simply have our equation 1 to be what? 0.1, and this is equal to what? A exponential raised to the power of what? B divided by what? We are dividing that with what? 283. That was our equation 1. So we have 283 here. But remember, we already know what's B. So if we substitute sub equation 3 into this equation, we'll simply have 0.1, and this will be equal to A exponential. What's your B? Your B was given to be what? 15350. So we have 15350. So this is 15350 divided by what? 283. So if you do that, you simply have exponential raised to the power of what? 15350 divided by 283. So you can divide both sides by exponential raised to the power of what? 15350 divided by what? 283 here. You divide this other side of your equation with exponential raised to the power of what? 15350 divided by 283. Why are we doing this? We are doing this such that we get the constant for your A. Are we together? So getting the constant value for A, this will simply what? Squash out, and you're left with what? 0.1 divided by your exponential. And what will that give you? You can punch that directly on your calculator. From what I have here, I simply have a value to be what? 2.78 times what? 10 raised to the power of what? Minus what? 25. Are we together? Do you have a unit? No, we don't have a unit because it is a constant. Now what you simply do is, since you've gotten to know what A and B, substitute your A and B into our given equation. And what's your given equation? Our given equation is what? Ut subscript t is equal to A exponential what? Bt. This is our given equation. So if you are substituting this into your given equation, you simply have an expression for what? Viscosity. And that was the question we were asked. So if we substitute all our given values, all our given constants into this equation, we'll simply have that U of t will now be equal to 2.78 times 10 raised to the power of what? Minus 25 exponential raised to the power of, what's your B? Your B was given to be 15350 divided by what? T. So this was the expression that you were asked to derive from your question. This is your number 1. So you've simply solved for number 1. Now your number 2 question, look up. Your number 2 question simply says, find the viscosity at what? 70 degree Fahrenheit. Are we together? So at 70 degree Fahrenheit, you simply get the viscosity of that what? Parameter, or of that what? Liquid. To get the viscosity of that liquid, remember we are to convert what? 70 degree Fahrenheit to what? Kelvin. And if you are to convert 70 degree Fahrenheit to Kelvin, what do? You introduce your equation, and your equation simply says what? 70 minus what? 32 multiplied by 5 divided by 9 plus what? 273. Now if you punch this on your calculator, you simply have that your temperature will be what? 294 Kelvin. So since you've gotten your temperature to be 294, substitute your temperature into your given expression to get what? The viscosity at 70 degree Fahrenheit. Now if we are to substitute, remember our given equation is what? Ut is equal to what? What's our equation? Ut is equal to 2.78. So here you have 2.78 times what? 10 raised to the power of what? Minus what? 25, right? Exponential raised to the power of what? 15350 divided by, remember in this case you don't have time, you've already calculated for your temperature, you've already calculated for your temperature to be what? 294. So you are substituting your temperature here to be what? 294. So what you simply do is you can simply punch this in your calculator and you simply arrive at the value for your viscosity. And what I have here is what? 0.0132 Newton seconds per what? Meter square. Always add your unit. If you add your unit, you are telling the examiner that this is the value for your what? Dynamic viscosity.